Alright, here we are, GEG P744, talking about our concept unit of the DK Series 1 Power Hub. I want to talk today on this concept of how it can be ramped up even in its infant stage of its original development a few years ago, of how we can take the corresponding magnets that we have, where these magnets spin over the top of these coils in a counterclockwise move. We have our motor coils in there as well as our power coils, and you can see how we have these coils are wound clockwise, showing the rotation of the winds, and we believe and we know that since it's been replicated that you can produce more power by putting washers and magnets behind the coils. Many people around the world now are doing that. Let's start up this unit off of our DC power supply. Let's give it a manual turn and start it up off of our 9-volt battery system. The 9-volt then kicks out, triggers out, unit comes up to speed and runs an RPM that will be pretty much set right now. We're running around 460. Now as we go over here to our metronome, and that's set on 100 right now. And as we increase, actually decrease what's going on, we take this down to 40 beats per minute instead of 100, and you can hear the RPMs go up because we're increasing the pulse with modulation. Now we go back and check our RPM. You see now that we're up around 476 to 480, and as we can increase what we're doing over here in DC voltage by coming up a few volts, we now have increased the RPM. We're at about 27 volts, holding a little over 600 milliamps, and now our RPMs are up to about 538, 540. So we take this back down to around 24 or so. And I wanted to explain that correlation because we have our high bypass filter sitting here in front that cause to have a non-load effect on the input part by blocking the low bypass frequency and power that comes in, so causing less of a lug. We have our resistive sand resistors there at a 2 ohm load on all 3 charging stations. These are our discharge caps. This is our back EMF circuit, but we can apply back EMF to all 3 of these. And you can see on our setup here that it's pulsing out about 390 or so when it comes up on the 40 pulse width beat, and 392, and here we're putting out around 400, 390, and back here on our back EMF circuit we're slightly higher, almost 500. Now that shows that we're able to take this content and use this concept to be ramped up, because as we want to increase coils distance, and let's go ahead and shut this off so I can show you some more characteristics of what's going on here. We have all our different relays set up for each one of our charging, our full wave bridge rectifiers, our Hall effects on the top that do the trigger and the signaling. And I know this is a lot to take in, but merely a concept of where we can take this up to over 2 kilowatts of power, because this is a battery charger, but this battery charger, which this goes into my home, And we can use these deep cycle batteries underneath here that hook up on those inverters. And over there we have manual switches that hook right into our system that I can go ahead and then turn on and run lights for just various testing phases. Like I said, this can be ramped up over 2 kilowatts of power in its existing state. We can put this in with wind power, which we're currently working on a flywheel system up out of Ohio with some colleagues of mine, and we're going to replace all of this circuitry that the drive force up here will be the flywheel and the wind turbine. So this can be non-disruptive technology, and this is what we want to hybrid into wind, solar, geothermal, hydro, you name it. If it's got an energy source, we can apply it to it. So I wanted to explain that, and have a good day. Be talking to everyone soon.